You don't see the world's most advanced weapons. You feel them in what you don't hear. Because under the ocean, power isn't measured by firepower on a parade ground. It's measured in decibels, in vibration, in heat, in the tiny, almost invisible mistakes that turn a perfect machine into a loud one. A single loose panel can sing at the wrong frequency. A pump can hum like a fingerprint. A shaft can transmit a tremor through metal the way a heartbeat travels through bone. And then there's the most dangerous sound of all, water itself betraying you. A bubble forms in low pressure and collapses. A snap of cavitation. A brief, violent noise that can carry farther than you'd ever believe in the deep. That's the real battlefield, not the surface, not the headlines. Down here, a submarine doesn't win because it is stronger. It wins because it can vanish. And the terrifying part is this. The ocean doesn't care that you're the most advanced machine ever built. The ocean doesn't negotiate. It doesn't forgive. It doesn't pause while you fix a mistake. It just applies pressure, relentlessly. And inside that pressure, inside the darkness, human beings place their lives in the hands of engineering. So tonight, we open the blueprint. Not to expose secrets, not to pretend we know what must remain classified, but to understand the innovations, the real, physical, measurable breakthroughs that made the world's most advanced submarines into the most survivable machines ever taken to sea. Because a modern submarine is not a ship. It's a self-contained world, a power plant, a listening post, a weapon system, a life support capsule, all wrapped in steel and lowered into a place where steel can be tested to the edge of its limits. And to understand why these submarines are so advanced, you have to start with the first rule of undersea warfare. If you can be heard, you can be hunted. For most of naval history, the sea was a visible arena. You could point at the enemy. You could track smoke on the horizon. You could see the silhouettes of ships and guess their intent. But submarines changed everything by moving the fight into a realm where vision fails. Underwater, you don't see first. You listen first. And that single shift turns engineering into strategy. Because the ocean is not silent. It's alive with sound. Waves grinding against the surface, storms rolling across thousands of kilometers, whales calling, ice cracking, cargo ships droning, distant engines vibrating through water like a never-ending thunder. In that noise, your submarine has one job: disappear. And if you can't disappear completely, then at least become so quiet, so confusing, so hard to classify, that even if someone hears something, they can't be sure it's you. That's the first pillar of advanced submarine design: stealth. But stealth underwater isn't a cloak. It's a discipline. It's 1,000 small design choices that all point to one outcome: reduce the signature. Not just acoustic signature, though sound is the king down here, but also magnetic signature, thermal signature, even the subtle patterns of how your hull moves through the water. And here is the cruel beauty of submarine engineering. Every solution creates new problems. You isolate a machine to reduce vibration, but now you have to route pipes and cables so they don't transmit that vibration anyway. You smooth the hull to reduce turbulence, but now maintenance becomes harder and more expensive. You change how the propulsor interacts with the water, but now you must manage flow, efficiency, and control in new ways. A submarine is a masterpiece of trade-offs. And the best boats aren't the ones that are perfect in one category. They're the ones that are quietly excellent in every category at once. Now imagine what that means in practice. Inside a modern submarine, you have rotating machines, pumps, motors, fans, compressors, because you must move air, circulate water, manage heat, and keep the crew alive. Every rotating machine is a potential noise source. Every pipe can become a speaker. Every structural connection can become a path for vibration. So designers fight noise the way surgeons fight infection, relentlessly, methodically, at every layer. They mount equipment on isolation systems. They create damping. They design foundations that absorb, not transmit. They choose materials and shapes to prevent resonance, because resonance is the enemy's best friend. Resonance takes a small vibration and turns it into a loud, stable tone that stands out against the ocean's chaos. And then there's propulsion, the hardest part to talk about without drifting into fantasy. People love the romantic idea that submarines are fast underwater, that they are sleek torpedoes in the deep. But in reality, Speed is complicated. Speed makes you loud. Speed creates flow noise. Speed increases the chance of cavitation. And cavitation is the betrayal of physics. It's not air in the normal sense. It's vapor bubbles created when pressure drops. Those bubbles collapse with violence. That collapse produces sound. And sound travels. So advanced submarines are shaped, built, and operated to manage the water around them. Because water is not just the environment. Water is the medium that carries your signature to the enemy. That's why a modern submarine stealth is not just about quiet parts. It's about controlling the physics of the ocean touching your hull. And that brings us to the second pillar. If you can't be seen, you must see. Because stealth without awareness is just hiding in the dark, hoping the hunter walks away. Advanced submarines aren't just quiet. They are intelligent. They are floating sensor arrays. They take a world of chaotic underwater sound and turn it into something usable. If you've never experienced it, imagine this. You're in a room with 100 people whispering at once. You can't see anyone's lips. You can't tell where each voice is coming from. Now imagine you must identify one specific person by their footsteps alone, through a wall, while the building shakes in the wind. That's the ocean. And sonar is how submarines survive inside it. At the simplest level, sonar is two ideas. Passive sonar listens. Active sonar talks, by pinging, and listens for echoes. Passive sonar is stealthier. It's patient. It's subtle. Active sonar can be powerful, but it risks giving away your position, your presence, your intent. So advanced doesn't mean always using active sonar like a flashlight. Advanced means knowing when not to. Advanced means understanding that the best sensor is useless if it makes you obvious. And beyond the sensors themselves, there is a revolution that many people miss: processing, classification, fusion. Modern submarines are not just collecting sound. They're analyzing it, filtering it, comparing it to libraries, separating the signal from the noise. Because a single contact isn't just a dot on a screen. A contact is a story. Is it consistent? Is it changing speed? Is it maneuvering? Is it another submarine? Is it a surface ship? Is it marine life? Is it the ocean playing tricks through layers of temperature and salinity? This is where the most advanced submarines become something more than boats. They become thinking systems. And that thinking isn't just done by computers. It's done by trained human beings sitting in dim light, headphones on, interpreting the deep like a language. But technology changes the way the crew works. It changes how information flows. And one of the most visible examples of that, ironically, because it's about seeing, comes from something the U.S. Navy publicly describes about its Virginia-class attack submarines. In Virginia-class submarines, traditional periscopes have been supplanted by photonics masts with visible and infrared digital cameras. Source: https://www.navy.mil/resources/fact-files/article/216955/attack-submarines-SSN. That single sentence is a big deal. Because the traditional periscope is not just a sensor. It's a design constraint. It's a physical tube that penetrates the hull and runs down into the control room. It dictates where the control room must be. It creates risk pathways for maintenance and damage considerations. A photonics mast changes that. It separates the sensor from the space. It turns looking outside into a digital feed that can be shared, recorded, and analyzed. And more importantly, it shifts the submarine from a mechanical era mindset into a networked one, inside the boat, not connected to the internet, but connected internally. Screens, feeds, multiple operators viewing the same imagery, infrared for night, visible for detail, data layered over visuals. In blueprint terms, it's the difference between a single eye and a set of sensors feeding a brain. And that is the pattern of modern submarine innovation. Digital systems replacing older mechanical limitations, not because digital is trendy, because digital is flexible. And flexibility matters because submarines don't live in a simple world anymore. Modern undersea missions are not one-dimensional. A submarine might spend days just listening, collecting intelligence. Then it might support special operations, quietly putting people close to shore. Then it might track an enemy submarine. Then it might be positioned as a deterrent. Its presence unknown, its potential undeniable. So the submarine becomes a multi-mission platform. And the only way to keep a platform relevant for decades is to build it like a system that can be upgraded. Because hulls last a long time. Electronics don't. Software changes faster than steel ever will. So a key innovation behind advanced submarines is not a single dramatic device. It's the design philosophy that anticipates change. The idea that you build not just for the mission today, but for the mission 10 years from now, 20 years from now, 30 years from now. That philosophy shows up even in public-facing Navy descriptions of how attack submarines evolve and modernize over time. Source: https:/www.navy.mil/resources/fact-files/article/2169588/attack-submarines-ssn. Now step back for a moment and look at what we've described. A submarine is fighting three enemies constantly: the enemy nation, the ocean, and time. Enemy nations adapt. They build better sensors. They train better crews. They deploy more assets. The ocean applies pressure, corrosion, and relentless mechanical stress. And time wears everything down: metal, seals, bearings, people. So advanced submarines are defined not only by what they can do on day 1, but by what they can still do on day 3000. Reliability becomes a weapon. Maintenance becomes a strategy. Redundancy becomes survival. Because under the ocean, you don't pull over to the side of the road. You can't open a window. You can't call for help in the normal way. Communication underwater is limited, difficult, and often slow by design, because transmitting can reveal you. So the boat must be able to endure. And endurance is not just fuel. On a nuclear submarine, endurance becomes something else entirely. Sustained power, sustained life support, sustained readiness. Even without going into classified details, the basic concept is clear. Nuclear propulsion changed what submarines could be. It turned them from underwater ambushers into true undersea ships, capable of remaining submerged for long periods and traveling vast distances without needing the surface for air. And once submarines gained endurance, the rest of the engineering race accelerated. Because if you can stay underwater longer, you now need better habitability, better air systems, better water systems, better heat management, better food storage, better psychological design, because humans are not machines. And this is where the story becomes human again. Because every time we talk about advanced submarines, we talk like the submarine is the hero. But the submarine is just steel and systems. The real hero is the crew. The people who accept that once the hatch closes, that's it. No daylight. No easy rescue. Just procedure, discipline, and trust. Trust in the welds. Trust in the valves. Trust in the engineers who designed the system. Trust in the maintainers who checked it. Trust in the watchstanders who will catch anomalies before they become disasters. And that trust is not emotional. It's engineered. A submarine is built around the idea that you will face failure, but you will face it in a controlled way. If something breaks, you isolate it. If something leaks, you contain it. If something overheats, you manage it. If something goes wrong, you respond with trained choreography. That is why submarine crews drill relentlessly. Because in the deep ocean, panic is louder than any propeller. And now we can understand why the world's most advanced submarines are so difficult to defeat. Not because they are invincible, but because they are designed to avoid the conditions that create vulnerability. They are built to be quiet, so they are hard to find. They are built to listen, so they can find others. They are built to endure, so they can stay in the fight longer than anyone expects. They are built to upgrade, so they remain relevant while technology changes around them. And they are built with human beings in mind. Not comfort, not luxury, but survivability, routine, and control. So what does this mean strategically? It means deterrence. Because submarines are the hardest assets to track reliably. A surface ship is visible. An aircraft is visible. Even stealth aircraft are detectable under certain conditions. But the ocean is a massive, complex, dynamic hiding place. And when you place a capable submarine inside it, you create uncertainty. For an adversary, uncertainty is expensive. It forces more patrols, more sensors, more aircraft, more ships, more time. And even then, there is no guarantee. That's why submarines influence strategy without firing a shot. Because the best submarine doesn't announce itself. It haunts the decision-making of the other side. It shapes routes, timelines, doctrines. It forces caution. And in modern conflict, caution can be the difference between escalation and restraint. Now, here's the uncomfortable truth, the one that sits beneath everything we've discussed. Under the ocean, engineering is not support. Engineering is combat power. A better pump mount can matter more than a bigger warhead. A quieter design can matter more than an extra knot of speed. A more accurate sensor suite and better processing can matter more than raw numbers of platforms. Because underwater warfare is not a fair fight. It's a hunting game. And the hunter who hears first wins. So when we talk about the engineering innovations behind the world's most advanced submarines, we're really talking about something deeper. We're talking about how humans learned to build machines that can survive and operate in a place that was never meant for us. A place where pressure punishes error. A place where silence is protection. A place where the smallest sound can reveal your existence. A submarine is a paradox. A fortress that moves. A city that hides. A weapon that succeeds by being invisible. And when you look at it through the lens of engineering, the submarine becomes one of the greatest achievements of modern design. Not because it is glamorous, not because it is loud, but because it works. Quietly, relentlessly, in darkness, under pressure. So the next time you see a black hull in a harbor, remember this. That isn't the whole machine. That is the skin. The real submarine is the blueprint behind it. Thousands of decisions made so that, when the hatch closes, a crew can step into a narrow steel corridor, feel the hum of machinery in their chest, and trust that every system will behave. Because once they dive, they don't just disappear from sight. They enter a world where physics is the enemy, silence is survival, and engineering becomes strategy. And out there, beneath the waves, the most advanced technology is not what you can show. It's what you can build and trust in total silence. In the deep ocean, power is measured in decibels. And the most powerful submarines in the world are the ones you never hear coming.